An international armada of science probes is converging on Mars. They are searching for evidence of past life, while testing technologies needed for humans to safely visit this desolate world. The Red Planet has beckoned generations of dreamers and spaceflight pioneers to imagine crossing the wide gulf between worlds. Long-standing questions hang in the balance. What is humanity's future in space? Could we actually make a second home on Mars? Mission planners have long known it is nearly impossible to land on Mars. The atmosphere is thick enough to melt spacecraft, which hit it going more than 16,000 kilometers an hour. Yet, it's so thin, even a wide aeroshell, plus a big parachute,
the parachute has deployed and we are seeing significant deceleration,
aren't enough to fully break the fall.
Heat shield set.
Perseverance is now slowed to subsonic speeds.
Percy, the Mars 2020 Perseverance rover, used an innovative system of rockets and an ingenious sky crane
Sky crane maneuver has started.
to gently touch down.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars.
But exactly how to land a crew of astronauts safely is a problem waiting to be solved. Percy is among the most sophisticated mobile machines ever made. Its small companion, Ingenuity, is the ultimate drone. Testing, for the first time, controlled flight on another world. From the striking images Percy and other probes send down, it's easy to believe Mars is very much like the deserts of Earth. For at least a century, visionaries have imagined if we could just get there, it shouldn't be too tough to explore in person. To pioneer a frontier of freedom and prosperity. And perhaps to make a backup copy of Earth's biosphere in case of disaster. But the real Red Planet is a trickster with a long history of fooling us. Colder than Antarctica, bone dry, harsh, toxic grit underfoot, and a constant rain of lethal radiation from above. A tragic world. The Mars we wish for has never been the Mars that truly is. For thousands of years, the bright amber planet has been toying with human imagination. As they orbit, Earth and Mars come closest together every 780 days or so. Called a planetary opposition, it's the best time to observe the Red Planet, which, over a few weeks, appears to slow down, backtrack, then speed forward again. Puzzled by this capricious retrograde motion, Egyptian skywatchers saw Mars as a hawk-headed humanoid deity, flying back and forth between the realms of the living and the dead. From its odd motion, Babylonian astrologers believe Mars to be a quick, impulsive, volatile god. On May 4th, 357 BCE, the Greek natural philosopher Aristotle observed the half-full moon passing in front of the red planet and realized that Mars must be farther away than the moon. But he would have been surprised by how much. Mars is about 200 times more distant. Chemical rockets that take around 3 days to get to the moon would take nearly 7 months to reach Mars. Future nuclear thermal rockets might cut that trip to less than 3 months. That's still a very long time to spend confined in a small spacecraft. And you can't just return home in a few hours or days if there's a problem. Astronauts in microgravity must exercise often. Bones become brittle. Heart muscles get lazy. At about 1/3 Earth's gravity, how will Mars affect human health over the long term? Around 150 AD, Greek mathematician and astrologer Claudius Ptolemy proposed that Mars and the other 4 wandering stars must circle Earth on a set of spheres. But 700 years later, Islamic astronomers began to find problems with Ptolemy's so-called epicycles. In 1543, Copernicus of Poland put the sun at the center of motion, and Mars' looping behavior finally made sense. About 40 years later, wealthy, obsessive Danish astronomer Tycho Brahe wanted to accept Copernicus' geometry, but he couldn't quite let go of Ptolemy. Tycho insisted that the immensely heavy Earth must be too lazy to orbit. But massive worlds do move. In the early solar system, the huge planet Jupiter may have migrated inward toward the Sun about as far as Mars' present-day orbit. Plowing through the solar nebula, Jupiter gobbled up much of the dust and gas, robbing Mars of its potential to grow larger. The stunted planet could attain only about half Earth's diameter and barely 11% its mass. As Jupiter and Saturn continued to migrate, they displaced billions of tons of icy rocks, flinging them inward. A deluge of debris lasting 3 million years. The Late Heavy Bombardment. Today, the high country of Mars' southern hemisphere has one very large hole punched in it, the Hellas Basin, the 3rd largest impact crater in the solar system. But the little planet may have been hit by something even bigger. As you fly from south to north, Mars' terrain sinks. From red and orange highlands down to green and blue valleys, Mars' whole northern hemisphere is a giant sunken ellipse, draping over 40% of the planet. If this is an impact site, the incoming object would have been about the size of dwarf planet Pluto. It would have totally remade Mars, probably shutting off its internal dynamo, erasing its protective magnetic field, and killing the chances for a life-sustaining atmosphere. When groups of would-be settlers do set sail for Mars, they must accept that they will never again take a breath outside their helmets or habitats. They will have spent months crossing the void to a desolate world with a lethal environment. In September of 1610, Galileo Galilei recorded the first telescopic observation of Mars. 26 years later, Francesco Fontana made the first known drawing of the planet, saying it looked like a very black pill. By 1649, the Dutch brothers Christian and Constantine Huygens had developed much better optics. Christian sketched an irregular mark on Mars. Living in the wetlands of Holland, he thought it looked like a big bog, so it became known as the Great Marsh, Syrtis Major. Huygens timed that rotating feature, finding the day length on Mars to be like Earth's. 7 years later, Giovanni Domenico Cassini refined that figure to 24 hours plus 40 minutes, very close to what astronomers measure today. Cassini also logged the first observation of Mars' south polar cap. Watching the changing faces of Mars, Cassini imagined it must be quite similar to Earth. "3 billion years ago, Mars may indeed have been Earth-like. Volcanoes building the atmosphere, steam and mist and flowing water filling early seas with more fluid than the Arctic Ocean on Earth. In 1997, Sojourner, NASA's first Mars rover, found the outflow of a cataclysmic flood. Beginning in 2004, the Mars exploration rovers Spirit and Opportunity found stacked strata of rock laid down by flowing water over thousands of years, and little rounded iron-rich concretions nicknamed blueberries that must have formed in pockets of silt lying under salty water. But what of water on modern Mars? NASA's Phoenix found evidence in 2008. Soft landing at a high northern latitude, its rocket plumes blew away surface dust, exposing some white material. Digging a shallow trench, the little probe revealed more, which disappeared within a day. And on the lander's legs, drops of liquid appeared, then changed. In August of 2012, the Mars Science Lab, Curiosity, began to roll. Trekking through dry stream beds, between the banks of ancient watercourses, and across the alluvial fan at the mouth of a long-dead river. Perseverance joined Curiosity in 2021, landing in a once-flooded crater, finding the clay-rich rocks of an ancient river delta. These hardy robot geologists found layered terrains, each built by episodes of flowing mud with dry times in between. But these wet periods ended long ago. Today's Mars seems a lifeless desert. A lonely landscape crying out for company. In 1698, Christian Huygens did not think Mars was so desolate. His last book, Cosmos Theoros, imagined that the worlds of the solar system must harbor plants and animals. Though they would be different from those on Earth, they probably led comparable lives. Huygens saw no reason that life on the planets should not be intelligent. And he also pointed out how important water would be to those creatures. The Moon is rich in aluminum, titanium, silicon, and magnesium. Asteroids add carbon, cobalt, platinum, molybdenum, nickel, and other elements. Mars has all of these, plus abundant iron and other metals, especially near its enormous volcanoes. But Mars' key ingredient is water ice, which can be split to make breathable oxygen and hydrogen fuel. Percy is testing this idea right now, breathing in carbon dioxide and electrochemically breaking out the oxygen. Water from beneath the surface, plus carbon dioxide from its atmosphere, can be rearranged to make methane and oxygen. Use that oxygen to burn the methane, and you can launch rockets. By making propellant on Mars, the cost of getting back to Earth drops by at least a factor of 5. To conjure up space-based civilization, we can bring with us only tools and talent, small factories and power generators. We must hunt and gather the rest. In 1704, Giacomo Filippo Maraldi guessed that dark rings around Mars' poles might be melt lines. Could the poles be ice caps, he wondered. 80 years later, Friedrich Wilhelm Herschel declared, yes, Mars' poles are water ice, and he thought that the broad, dark equatorial patches must be oceans. Herschel daydreamed what it might be like to sail those waters. Mars probably lost its oceans before life emerged out of the seas on Earth. The northern desert lowlands, the flattest topography on any known planet, look like the floor of an ancient sea. Up to 4 kilometers deep, Mars' polar ocean may have covered a third of the planet. In 1785, Herschel speculated that Martians probably enjoy a situation similar to our own. But he realized the Martian atmosphere must be very thin. It is thin. The planet is enveloped in sparse carbon dioxide. There's very little water in the air. But there is methane, which could be coming from hot underground geology. But the methane level sometimes rapidly blooms, then quickly disappears. And that has a lot of experts wondering, might something be living below the surface? In 1788, Johann Hieronymus Schrader proposed that Mars has no solid surface at all, just drifting clouds and misty rain. But Schrader's shifting scene was probably just due to the unstable air of Earth above his big telescope. The true story of Mars' atmosphere is becoming clearer. Going back at least 1 billion years, intense ultraviolet radiation from the sun and the sputtering solar wind bombarded the small planet. With its low gravity and frail global magnetic field, Mars could not hold on to its protective gas envelope. Most of its air was lost to space, and the rest of its water absorbed into the ground. Back in 1830, none of this dreadful history was known. Johann Heinrich Madler and Wilhelm Beer crafted the first fairly accurate Mars maps. They placed their zero longitude line through a feature that will later be named Sinus Meridiani. Meridian Bay. This is what Meridian Bay looks like from the ground. The Opportunity rover explored it for 13.5 years, sending home images of the stark, withered landscape. It's easy to imagine standing on Mars yourself, gazing at the intricately weathered rocks. Nearly everywhere our probes look, they see evidence of past liquid water. Though there are no oceans today, there's plenty of hidden ice. The Mars Reconnaissance Orbiter recorded eroded cliff faces, exposing compacted frozen water, in some places more than 100 meters thick. On passes over the poles, MRO's radar revealed up to 2 kilometers of ice. It's been laid down in layers, suggesting that Mars' climate may cycle between warm and cool times. Zooming in from orbit, we can see dark streaks that appear and disappear seasonally on the slopes of steeper craters. They look a lot like desert rain gullies on Earth, and many researchers thought they might be flowing salty water. New analysis suggests that the larger ones, at least, are dry. Streams of rounded sand grains tumbling over one another, flowing like liquid in the low gravity of Mars. But the small ones seem truly wet. In 1862, astronomer Camille Flammarion picked up the idea of intelligent aliens, publishing the first of his 8 books about life on the planets. The Plurality of Inhabited Worlds became an all-time bestseller. Charles Darwin's notion that species develop in response to their environment led Flammarion to speculate that various planets would cause creatures there to be unlike those of Earth. Drilling into the rocks, Mars rovers have shown the building blocks of life to be plentiful. Clay minerals would have filtered salts and harsh compounds from the primeval flowing waters. Many types of microbes now living on Earth almost surely could have survived on ancient Mars. But no photos, fossils, or direct chemical evidence of life have yet turned up. Around 1864, the Vatican became concerned about the state of grace of the Martians. Father Pietro Angelo Secchi of the Roman College Observatory began to chart where they might live. He renamed Huygens' Syrtis Major feature, calling it the Atlantic Canale. That word simply means channel. Secchi intended no reference to intelligent design, but his term canale would cause much confusion over the following years. At the same time, in England, astronomer William Dawes made Mars maps of his own. Dawes was extremely nearsighted, but his charts were more detailed than any before. Sensing a great story, science writer Richard Anthony Proctor blasted the Dawes maps out to the public. The Suez Canal was completed in November of 1869, making news around the world. The Panama Canal was in the planning stages, and many people made a connection between the strait Canale on Mars maps and these great works of engineering on Earth. There are many ancient water channels all over Mars, but there's no evidence of technology in their shapes. Mars came again into opposition in 1877. Nathaniel Green, an artist by day and astronomer by night, painted the most accurate Mars chart yet. Over in America, the self-taught astronomer Asaph Hall noticed something no one else had. Two tiny moons. Phobos and Deimos may be bits of Mars, flung into orbit by giant impacts long ago. Or they may be asteroids captured by the planet's gravity. With Mars particularly close, within just 56 million kilometers of Earth, Giovanni Schiaparelli began to map it. Though he, like Dawes, was nearsighted and colorblind, Schiaparelli was somehow able to extract more from the telescope than others. He too called the lines he saw on Mars canali, giving them whimsical names from classical literature that are still used today. Some Mars oppositions are closer than others. While Earth's orbit around the Sun is nearly circular, Mars' orbit is much more elliptical. During Mars' southern autumn and winter, that hemisphere is tipped away from the Sun, and the whole planet is farther away, making those seasons longer and colder. With the next close opposition, in 1879, Schiaparelli came to believe he was seeing pairs of straight canali. Harvard College Observatory's William Henry Pickering declared that Martian canals were only visible because plants were growing along their banks. All speculation about large engineering projects by smart Martians was put to rest on the night of July 14, 1965, as NASA's Mariner 4 flew by Mars. In the probe's 21 images, Mars looked much more like the Moon than the Earth. Worse, Mariner couldn't find a protective magnetic field. Harsh solar wind and cosmic radiation would have been scouring the planet for millennia. It's tough to imagine how even primitive life could survive here. But back in 1892, Camille Flammarion was still filling his imaginary Martian canals with water. He speculated they were the rectification of old rivers by the inhabitants for the purpose of general water distribution, and that the actual habitation of Mars by being superior to our own is very probable. Pouring more into Flammarion's illusory waterworks, Pickering asserted that he had observed up to 40 lakes. At about the same time, a wealthy, world-traveling American diplomat was feeling like he needed a career change and a personal passion project. Percival Lowell had read Flammarion's books, and he made plans to look for Martians during the coming opposition of 1894. Pickering helped Lowell rig 2 telescopes on a hilltop in Flagstaff, Arizona. The new Lowell Observatory stared at Mars all summer long. But Lowell, an untrained observer, saw only what he believed. He sketched a planet-wide irrigation system transporting billions of gallons of melted polar snow to equatorial oases. The irrigated agriculture projects of an advanced race. But during the same opposition, astronomer Edward Barnard, wielding the California Lick Observatory's larger refracting telescope, could not find a single straight line anywhere on Mars. And when the Lick's William Campbell examined Mars with a spectroscope, he saw not a trace of water. English astronomer Edward Maunder demonstrated how straight lines on Mars could easily be optical illusions. Undeterred, Percival Lowell sprinted across America on a lecture tour in 1895, promoting his book named simply Mars. A story-thirsty public bought his tales of Martian waterworks by the thousands. The real Mars is a parched planet. Though tilted rocks tell us there were lakes here long ago. Today, dust devils swirl across the barren terrain. The Spirit rover caught one in the act, 486 Martian days after landing. Curtains of desiccated grit sweep up into the hazy sky from rugged canyon cliffs. Dry, sandy landslides garnish steep crater walls and clump on the floors. Percival Lowell began observing with an even bigger refractor in 1896, but still could not see his glaring error. Lowell carried on for 20 more years, hallucinating over 450 canals with vegetation, seduced by the drama of a desperate civilization bravely combating global climate change as their dying world dried to a planetary desert. In fact, Mars' climate did change radically, but it happened long before Lowell's time. Without a large moon to stabilize it, Mars wobbles tens of degrees over hundreds of thousands of years, much more wildly than Earth. When Mars points a pole toward the Sun, billions of tons of CO2 might be released, unleashing epochs of greenhouse warming. This might melt subsurface ice, letting the water flow. But the temperate times can never last. In his 1899 novel, The War of the Worlds, H.G. Wells found drama in the doomed planet. An advanced race of Martians comes to conquer Earth and enslave humans as work animals. In 1976, Earth sent 2 Viking landers, not to subjugate, but to investigate.
ATS is green, 1.5 degrees per second max, 0.2 Gs. 8 feet per second. Touchdown, we have touchdown.
They found very active, intriguing surface chemistry, but evidently no life. Back in 1905, the idea of a living Mars captured Lowell Observatory's Carl Lamplund. He claimed to have photographed 38 canals. Now, it's vital to remember, most of these observers were good astronomers, wielding the best telescopes of their day. Yet, they saw what wasn't there. A lesson, perhaps, for those who, today, dream of settling Mars. In 1909, at the Meudon Observatory near Paris, astronomer Eugene Antoniadi could find no linear canals. Yet, the public had been seduced by the idea of an alien civilization. American novelist Edgar Rice Burroughs released the first of his 11-volume tale depicting heroic John Carter on a fictional Mars, the desert planet Barsoom. Today's Mars rovers are finding a desert world too. Curiosity trekked around a wide field of dark sand dunes. Rolling like waves on an ocean, the sandy mounds slowly migrate across the terrain. The orbiting HiRISE camera caught Curiosity at work in what's known as the Bagnall Dune Sea. In 1921, Mount Wilson Observatory astronomers measured surface temperatures on Mars, finding them to swing wildly, from 15 Celsius at midday to a lethal minus 85 Celsius just before sunrise. Astronomer Walter Sidney Adams found only vanishingly tiny quantities of oxygen and water. At the Yerkes Observatory, Gerard Kuiper showed the Martian air to be nearly all unbreathable carbon dioxide. Yet Mars continued to entice explorers. In 1949, rocket pioneer Wernher von Braun wrote Project Mars It was a sci-fi novel, but full of factual engineering and a familiar plot. A multinational crew from Earth visits intelligent humanoid Martians as they desperately try to save their world. A year later, Ray Bradbury's Martian Chronicles placed a human colony on Mars to escape a nuclear war-devastated Earth. The first thermonuclear bomb was tested in 1952. In the same year, von Braun published an enhanced Das Mars project, adding a broad technical workup for a large-scale space program. After nearly 1,000 launches of people, propellant, and parts, a flotilla of 10 spaceships and 70 crew members would journey across the gulf between planets to spend 444 days on Mars. Das Mars project was a rough draft for what would become NASA's Mercury, Gemini, and Apollo projects. In 1955, Paramount Pictures released Conquest of Space, modeled on von Braun's adventurous plans.
I can give you a confounded little reason for this attempt to reach Mars, and no assurance at all that it will even be successful.
To successfully reach the Red Planet quickly, engineers realized, might take more power than chemical rockets can produce. At the U.S. Los Alamos National Lab, Project Rover began an effort to harness atomic fission to drive spaceships. The astronauts' crew capsule would be placed many meters from the radioactive engines. Getting to Mars faster would cut astronauts' dose of solar and cosmic radiation. Project Orion, a different approach to nuclear rockets, started in 1958. The idea: detonate nuclear bombs behind a ship to push it along. It's called pulsed plasma wave propulsion. Outrageous as it seems, this method could offer rapid transport to Mars and the rest of the solar system. By 1961, the U.S. nuclear rocket engine NERVA program had accumulated 17 hours of engine testing. In the Soviet Union, engineers were working on nuclear thermal rockets of their own. As late as 1962, the U.S. Air Force was still making Mars maps with straight canal lines.
Someday, a manned trip to Mars and return may become the mission assignment.
To accomplish that assignment, Kraft Ehricke, a visionary German-American engineer, introduced the idea of ganging together clusters of nuclear rockets. He thought his modular approach could bring Mars and Venus within reach as early as the 1970s. And he identified the most efficient launch windows to reach these planets. Ehricke passionately believed that human expansion throughout the solar system is a fundamental right, and that we are at our most dignified when we apply the laws of physics to elevate and protect our individual freedoms. Ehricke's and von Braun's visions would drive the Boeing company to propose the Integrated Manned Interplanetary Spacecraft concept in 1968. It bundled up to 5 nuclear thermal stages to propel astronauts and probes to the nearest planets. It would have cost half again as much as the Apollo moon program, but it might have delivered the first crew to Mars by 1986. The U.S. put boots on the moon in July 1969. humans had finally touched another world. With the moon landings fresh in mind, many people expected the United States to next target sending astronauts to Mars.
Hey, Houston, we've had a problem here. Can you say again, please? Houston, we've had a problem.
But President Richard Nixon, fearing the political consequences of a catastrophic mission failure, would support only a space shuttle. Though 4 subsequent U.S. presidents would ask for various Mars programs, human space activities would remain confined to low Earth orbit for more than half a century. By 1990, some planners realized that cumbersome bring-everything-with-you space programs were not workable. To remedy this, engineers Robert Zubrin and David A. Baker proposed the Mars Direct concept. Its motto, travel light and live off the land. By making rocket fuel from the planet itself, explorers could ensure themselves a ride home. By 1993, key ideas from Mars Direct had found their way into NASA's Mars Design Reference Mission. But consistent congressional support for humans to Mars never materialized. In recent years, giant aerospace companies and small private startups have all adopted bits of Mars Direct. Boeing's Affordable Mars mission would send a solar electric sailing ship to reconnoiter from low orbit. Astronauts would descend, protected by an inflated aeroshell, touching down like the Apollo missions, to find a previously landed habitat waiting. They'd return to orbit like last century's moonwalkers for the long trip home. In contrast, Lockheed Martin proposes a Mars orbiting base camp. It's conservatively built by stacking pairs of modules. 2 tank farms, 2 habitats, 2 rocket propulsion units, redundancy for safety far from Earth. Astronauts make sorties to the surface with a single-stage lander. But this surface-to-orbit shuttlecraft doesn't depend on fuel made on Mars. Younger, more aggressive companies are thinking bigger. Elon Musk's space exploration company is developing Starship. It's designed to transport massive payloads and many people across Earth and to orbit, and eventually bring millions of tons of material to the surfaces of planets, moons, and asteroids. Like von Braun and Ehricke before him, Musk is focused on solving transportation around the solar system. SpaceX's eventual goal: make Earth life multi-planetary by building civilization on Mars. In friendly competition with SpaceX, Blue Origin, led by Amazon founder Jeff Bezos, is quietly developing large boosters of its own. Blue Origin's vision is also to extend civilization into space, to preserve Earth's climate and maintain it as a flourishing biosphere by moving heavy industry and power generation off the planet. And eventually, constructing city-sized, free-flying habitats from materials already in space, on the moon, asteroids, and comets. Video game makers, too, began to promote the adventure of populating Mars. And the rest of the solar system. And some visionaries foresee the eventual terraforming of Mars, warming it up, making it as Earth-like as possible. But to do this, these world builders must find enough greenhouse gases to heat the planet, then continuously replenish its thick atmosphere and constantly restore its water as the vapor escapes to space. Still more challenges lurk on the trickster planet. Mars' surface is everywhere loaded with toxic caustic perchlorates, up to 1% of the sands, putting astronauts at high risk for thyroid problems and cancer. Other invisible dangers cascade from the sky, unhindered by the thin atmosphere. The constant rain of cosmic rays from interstellar space and highly energetic particles from solar flares pelting the planet. Despite the many intriguing renderings of domed cities on Mars, settlers for many generations to come will have to spend most of their time in thickly roofed shelters or underground. Yet, there may be hope. The rise of autonomous machines, advanced robotics, artificial intelligence, and augmented reality can extend human senses to the surface of the red planet. And someday, we may send devices to terraform Mars on their own. Human emigres from Earth could eventually build communities on a ready-made planet. In 2033, Mars will come into a particularly favorable position for launching human crews. But who will go? And why? Mars has seduced so many seeking notoriety, promising an entire new world to explore or exploit. Ingenious engineering may find elegant solutions for how to get us to Mars. But what becomes of us once we get there?